Let's have a look at the function of a function rule, best explained by a series of examples. I've written down some bookwork here that we'll have a look through briefly. Basically, y needs to be of this form. It's a function of a function. So here you've got g of h of x. If you let u equal the h of x part, then you can see that y would be g of u. And then this is the formula. dy dx, when you differentiate, is dy du du dx. You differentiate the something inwards, the something, and then you multiply that. So you differentiate the something, dy du, and multiply that by the something differentiated by the something differentiated. I think that's the best way to say it in words. It's not totally clear, but it's just a reminder. So here, if we let u equal x cubed, see it, sine u, and u can equal x cubed. So sine of something. So that's now a standard function. So if we're talking about sine u, we can get sine u differentiates to cos of u, and then multiplied by the something differentiated. Well, when we differentiate du dx, we get 3x squared, don't we? So dy dx then would be dy du du dx, so these two times pi together. So 3x squared cosine u. And at the end of the problem, make the substitution back. Cos of u is x cubed, so it's 3x squared cos x cubed. So I was just doing the long-winded way there to start with, the first time we've seen it, just to see if we can see the pattern. So differentiate the something multiplied by the something differentiated. Let's see if we can see the pattern here. Sine of something, differentiate the something, goes to cos of something. Okay, here, multiplied by the something, that's the x cubed now, differentiated, which goes to that. So you're like peeling an onion, alright? So we'll just do examples, and hopefully the penny will drop when we get used to a load of examples. See this one, cos of something? So cos of something differentiates to minus sine of something, doesn't it? So 6x multiplied by the something differentiated 6. So you could put the 6 at the front, couldn't we? So let's do that. Minus 6 sine 6x. Alright, so here, next one. E to the something differentiates to e to the something, doesn't it? Multiplied by the something differentiated 3. See it? It's like taking layers off an onion until you run through the whole problem. Something to the 4, differentiate that. Dy dx then would be 4 times the something cubed multiplied by the something differentiated. So I've differentiated the something. In my mind's eye I'm seeing u to the 4. I'm differentiating that as 4u cubed multiplied by the something u differentiated, which is 3. So we end up with 12. 1 plus 3x cubed. Okay, so here, see that in your mind's eye would be the u. So dy dx, dy du, log u goes to 1 over u, multiplied by the something differentiated, which is cos du dx, dy du du dx. Perhaps it's better to think about it in those terms. This is to the power half, so it's something to the power half, isn't it? 5x plus 3, I think it was, power half. So there's your u, isn't it, in your mind's eye. So dy dx, differentiate the something, u to the half goes to half of u to the minus a half, one less, power rule, multiplied by the something differentiated, u dx is 5. So we end up with 5 over 2, don't we? So let's just put it in here. Okay, here's our u function here, log of u, we can differentiate that. So dy dx is dy du, log u goes to 1 over u, which is x to the 4th, multiplied by the something differentiated 4x cubed. So So we end up with 4 over x. Next one, we think of this, I know it's written like that, but this is what we actually have here is cos of x squared. Something squared. So there's our u then, and we can differentiate that. We can differentiate du dx there. Dy dx, dy du, u squared goes to 2u, multiplied by the something, differentiated, cos goes to minus sine. This was cos x, wasn't it? So we end up with minus 2 sine x cos x. That's easier on the eye there, isn't it? So I hope you can see it from those first few examples. If I go back to the first ones, see it, sine, if we let the x cubed be u, sine u, dy du is cos u, times du dx, which would be 3x squared. So we just basically just cut this long story short and we just write this. So it's cos u, that's dy du, sine u goes to cos u, multiplied by du dx, and this differentiates to 3x squared. Okay, so that's how you do them. We'll do a few more now, but the next ones we're going to do are going to be a bit more complicated. Okay, here are the more complicated ones. See, this is something cubed in the first instance, but we've got not just 2 layers here, we've got like an onion with 3 layers here because it's something cubed, but the something itself is a function of a function as well. So the first instance is to think of this as being IU. So dy dx then, we can do it in one fell swoop, we just got to be careful. U cubed differentiates to 3 times u squared, which is the sine 2x, multiplied by the something differentiated, but the sine 2x now differentiated, if we think about that, is sine of something, isn't it? And that differentiates to cos of something, multiplied by the something differentiated, which is 2. So did you see how we unraveled it? And now we've got 6 sine squared 2x cos 2x. Let's just do a few more examples and hopefully it becomes clear. Log of something to the 4. Basically, we've got to think of all of this as u, haven't we? This to the 4 is log of u. So dy dx then is equal to log of u differentiates to 1 over u, multiplied by the something, 1 plus 8x to the 4 differentiated. And now, when we think about differentiating that, we can think of it as this to the 4. Call it v if you want, because we've already thought of the symbol u in our minds. Now let's just keep using u. So log of something goes to 1 over something, multiplied by the something differentiated. The something is this to the 4, and we can think of that as something to the 4. So when we differentiate that, we get 4 something cubed, don't we? Multiplied by the something differentiated, which is 8. So we go from the outside in. This was 1 plus 8x, wasn't it? Let's do it again. Here, this is a pain because this is now a product rule. We need to tidy this up, of course. We got 32 over 1 plus 8x here. Okay, this is u and this is v. The u is fine, but the v part of the product, because this is a product, is of its own, in its own right, a function of function, isn't it? So when we work that out, we've got to be careful. So dy dx is u, dv dx plus v times du dx, and that's okay. So this, everything else is okay. The only thing we need to worry about is dv dx. Now dv dx is a subproblem in its own right. It's something. So again, I'm just going to abuse the notation by just putting another u here. It's something to the 5. So when we differentiate a function, it's u to the 5 differentiates to 5u to the 4 multiplied by the something differentiated, which is 3. There we are. So that's what we've got. We've got 15 x squared 3x plus 1 to the 4 plus 2x 3x plus 1 to the 5. And we could tidy that up still further, of course, using algebra, couldn't we? Here we've got a product again, so use the product rule. dy dx is u times dv dx plus v times du dx. Now, I put two question marks because both of these subproblems are in themselves functions of a function. So it's u, that's fine. dv dx, sine of, in our subproblem, that's u. So sine u goes to cos u, doesn't it? So that would be cos u, which is 6x in this instance, multiplied by the 6x differentiated, which is 6, plus v times du dx. E to the something differentiates to e to the something, multiplied by the something differentiated. Okay? So it's 6 e to the 3x cos 6x plus 3 e to the 3x sine 6x. There we go. Okay, good. Next one. This is a quotient, u over v. So it's really hard, isn't it? Let's have a go at it. Just use the quotient rule then. V, x plus 1 squared, times du dx. Now this is e to the something differentiates to e to the something, multiplied by the something differentiated. Okay. V du dx minus u times the v to the x. Something squared differentiates 2 times something to the 1, doesn't it? Multiplied by the something differentiated, which is 1. All over. So that was v du minus u dv, all over v squared. This squared is x plus 1 squared and squared again. So that's power 4. And we could tidy that up, of course. So that's equal to, we could take an e to the 2x outside the bracket and an x plus 1 and a 2, and we're left with just the x plus 1 here minus 1, isn't it? Minus 1, because that's a 2 e to the 2x x plus 1 times 1, so there's the x plus 1, yeah. So 1 take 1 is just x. So the top simplifies to just times x over x plus 1 to the 4, which is equal to 2x e to the 2x over x plus 1 cubed, isn't it? Okay, good. Now we'll do the last one. So I'll scratch this and make a bit more room and see if we can make some headway on the last one. Okay, let's have a look at this one. Okay, so dy dx then. Now, let's have a look at it. Dy dx. It's a quotient rule. U over v, isn't it? So it's v cubed times du dx. Now this something squared 2 times something to the 1. So that would be 2x plus 1 to the 1 multiplied by that something differentiated 2. That was v du minus u. So I'll put it under here, minus u plus 1 minus u times the v dx. This is this cubed, something cubed, 3 times something squared multiplied by the something differentiated, which is 3, all over v squared, which is 3x minus 2 to the power 6. And we could simplify that. Time doesn't permit me to do it in this vid, but we could simplify it with the algebra and see what it comes out at.